Hello, my name is Alyona Bulda, and here is my colleague Oleg Pavlikov.
Hi.
We both work in Exactpro and have participated in a set of quality assurance projects. Some of the challenging projects were about FPGA-based solution testing. So today in our presentations we are going to highlight the main common challenges which could be around testing of FPGA. Actually, we'll be speaking about the testing at the confluence of non-functional and functional testing. So, why FPGA?
We assume that most of audience is familiar with FPGA and the possible benefits that one can gain by using that technology. As an introduction to our presentation, we would like to highlight just several well-known key advantages of FPGA-based products. First is performance. Taking the advantage of hardware parallelism, FPGAs exceed the computing power of digital signal processors by breaking the paradigm of sequential execution and accomplishing more per clock cycle. The second one is throughput. FPGA has many high-speed input-output pins to interface with memory, Ethernet, etc. It has dedicated channels for peripherals, unlike CPU, which peripherals share a bus. And the third one is reliability. As you know, usually software programs are built upon several layers of abstraction to help schedule tasks and share resources. They are at risk of resource contention, deadline violations, and incompatibility, etc. On the other hand, FPGA circuitry is a hard implementation, which in theory is deterministic and well predictable.
Well, the advantages are great, but to achieve them, FPGA-based systems should be tested properly and the test coverage should be adequate. This is complex due to a number of reasons, but we will attempt to summarize them. So most of the sophisticated FPGA-based systems are designed in such a way that the part of the logic is implemented on FPGA and another part is implemented on the software. So why is this happening? It's usually due to different reasons. It could be due to limitations of the selected FPGA board, so the developers have to simplify their algo. It could be also due to overall goal that the project team working on while developing the platform, because sometimes they are more curious about the performance characteristics rather of the part of the platforms rather than the entire system as a whole. So in certain cases, validations could be excluded from the software part. And let's say here could arise a number of issues. A challenge can also arise from the necessity to duplicate the logic in both sides, FPGA and the software. Another challenging area is building up the QA environment for testing and live environments, because it actually costs a lot, and every time you will be asking yourself whether you need to set up an additional QA environment for testing or not. Of course, in this case, as a result, QA team will have less time and fields for being more flexible.
Let me emphasize the main testing challenges of FPGA-based products. The cost-efficient environment is a challenge. One of the major contributing factors for a successful QA process is a sufficient number of test environments. This is a challenge for testing activities for FPGA-based product due to high cost of FPGA boards. Maintainability and operability of test environments is also a challenge. The presence of FPGA board in the ecosystem of application also implies the presence of additional hardware and software components for monitoring or deployment purposes. And this, in its turn, means that the maintainability and the operability of such environments is also a challenge. And test case development is a challenge as well. It is a really complicated process to create a proper set of test cases with a convincing level of coverage due to a hybrid nature of applications, which has FPGA-based components.
Okay, let's move on. What are the typical issues that are common for FPGA-based solutions? There are actually two main streams where issues could exist. First type of issues could stem from the duplication of logic from the software and FPGA parts. There could be due to a number of reasons, of course. So the first one is it could be due to different data type representation. It could be also due to different data structure implementations, such as layouts or different layers of the implemented algo, and so on. And it could be also due to the fact that the same logic is somehow duplicated in both sides. So in software, which is communicated to FPGA, and on FPGA as well. Another type of issues could be encountered in the processing flow of FPGA-based systems. When control part is implemented on a software, in some cases it could slow down the processing event of the hardware queue. So in that particular cases, developers try to avoid such bottlenecks, excluding the and simplifying the communication between the FPGA and the software part. And of course, this leads to some sort of defects. Another type of fascinating issues could arise from the hardware resources which are used by the platform as a whole. So some FPGA boards have its own clock time sources and can use it for processing, while at the same time, software part is relies to hardware clocks. So it's also makes the problem in synchronization between software and FPGA. Okay, let's talk about the ways to tackle quality assurance challenges.
So, what are the possible solutions for environment availability challenge from QA standpoint? Unfortunately, we don't really see an easy way out here, because if FPGA is a part of your application, you have to use test environments which have enough amount of FPGA on board. Otherwise, you won't be able to prove the quality of your product under the test. So you have to keep it in mind when you plan the budget. As a possible workaround, we think that at early stages of testing, just to prove functionality, a low-cost analogs of FPGA selected for the project can be used. But you need to ensure that a chip of such low-cost analogs performs adequately and is capable enough to provide at least the same level of functionality.
What else can be considered as an enhancement for FPGA-based solutions? A redesign of the implementation part may be needed. It could be done either with lessons learned or designing the platform, keeping in mind the challenges we have discussed here. So how can this be done? The answer could be to exclude the logic duplication from the software and FPGA. And another way is to implement the platform in such a way that it's fully on FPGA. However, this, of course, will make the development process more complicated and challenging.
In order to reduce the impact that the presence of FPGA in the applications infrastructure has on the maintainability and the operability of the environment, the following can be recommended. First, make a firmware upgrade process as easy and transparent as possible. It is possible to make a big step in improving of maintainability and operability of the environment by providing a set, let's say, of automated deployment tools and avoiding transition of servers into a special programming mode. Consider a possibility to keep several FPGA firmwares on the same card. This may allow to reduce time frames required for rollback of firmware under the test. And ideally having a single OS driver version, a single version of operating system driver will reduce the time, the complexity, and the number of support teams which are required for rollback and deployment activities in live or test environment.
Actually, this concludes our presentation today. We are ready for questions, and please raise your hand if you have one. I think we should consider it a success. Oh, no questions?
Thank you.
Thank you.